Hi, Chris Kuzmal here. We've got most of our stack class testing done, but one test we have not done is to find out what happens when we do too much pushing. What if we push too many things onto the stack, more than will fit into the stack as allocated? Our typical stack, we allocate 5 elements to our stack, and we haven't pushed more than 5 elements onto the stack. So let's write a test called test too much pushing. Okay. And of course, it hates on us because we haven't defined it. It's a classic, this standard thing here. So static void test too much pushing. And now, of course, I shouldn't have any errors. I should be able to just run my code. I should still get 6 passes and 0 failures. And that's lovely because, of course, test too much pushing doesn't do anything. So let's have test too much pushing do the same thing as test pop when empty does in terms of what kind of stack does it create. That points up something, maybe later on we want to create a stack of different size and do a sort of a scaling test. But there is a point where we might finally say, okay, look, we've done enough testing, because there's always going to be more tests you can do. And God forbid that I be on the record saying that you shouldn't write more tests, but there is a limit. So here I make my stack of dishes, and of course my dishes are actually numbers, integers. So I push the number 3 onto my stack called dishes, and this also should not produce an error. Of course, we don't count passes or fails yet. We haven't quite figured out whether or not this test passes. I mean, we could do a pass increment here because we haven't done too much pushing, but we want to do too much pushing and then get an error, get an exception. And the question is, like, how many pushes is too many? Well, it seems like new stack of 5, that suggests 5 should not be a problem. So let's push 5 times and expect no error. And we push 5 times and we get an error. Okay, now, if we look at the definition of a stack as given to us by Corman Liserson and Rivest, and this is an ancient edition, it's like 30 years old. They may have updated the stack implementation. It's the very first thing in the elementary data structures chapter, which is chapter 11 in the edition that I have. But they actually explicitly say they're not going to bother with what they call overflow, which is too much pushing. In other words, they don't address that potential error. The issue here is that the way that we've defined our stack is that we basically don't use the first element of the array that's the underlying representation of our stack. And so as a result, these elements get pushed on to our stack onto array element 1, 2, 3, 4, and 5. But in Java, the 5th element of an array of size 5 is actually beyond the index. And indeed, we get an array index out of bounds exception. So this behavior is not surprising. And you could argue that it's a bug in the specification of a stack as given by Corman Liserson and Rivest. Or you could say, they actually never specify the constructor. There's no constructor. And our constructor here that has a 5 here, we could do a little trick under the covers to fix this apparent bug, okay? And what we could do is in the constructor, where is the constructor? Right here. Rather than allocating max size to the array, we could allocate max size +1, all right? So maybe that's what we should do. I'm not thrilled with it though, because even though this is something that's happening at a place where the person who's using the stack doesn't see, with the way we use the stack, nothing changes. We run the code after having made this modification, and we've gotten rid of the failure, the unexpected failure. But our test case should still assess whether or not the behavior is correct. And so we need to finish writing our test case, which we'll do next video.